So now we can add a flash effect to our sprite so it'll flash in and out of visibility. And I brought up a player CC so we can see how we did it in our sprite is visible method for our player. And it's just this: take the timer, which is currently active, get its current time, and then divide it by some period, so the invincible flash time in this case, and then modulo it by the number of segments you want. So it's just the same logic, and you can watch that video again where we implemented that. But I'm just going to do if timer, and there's a trick about the timer that I'll get to in a second. Dot current time divided by k flash time, which I will define as being equal to 25. Or, let's call it k flash period. I like period better because it's happening periodically. And then it's going to go one part visible, one part invisible. So this will be if it's visible. So the thing is, our timer isn't actually running yet, and that's a problem I'd like to fix in our constructor for timer, so we can optionally start it running. Because right now we just set it to expiration time, so it starts out not running. So I'm going to add in a bool start active, and I'm going to default it to false, because that's how we're using it right now. And then we can, inside of current time, when we're initializing current time, we say if start active is true, then we can start at 0, or set our current time to be 0. Otherwise, we set it to be our expiration time. So we don't need player CC anymore. So this should do it for us. In player CC, we were also checking if timer.active. But we don't need to do that because if our timer is, here we can change this. So if our timer is not active, I'm just changing this from not expired to active. Same thing, but it reads cleaner. So if our timer is no longer active, we will be removing our head bump particle and it'll be expired. So we don't really need to check if it's, yeah. So I'm gonna build and run, because I think this should flash for about 600 milliseconds, so hopefully we can see it. Building song, building song, building song, building song. And I didn't see it flash. Oh yeah, because we're still using, see, there we go. So we're still using that start active as false. So let's make a true and just say start active. I'm not going to make another constant for this just because it's like, that's the only place I use it. Just make a comment. Yeah, so I could see it flashing. It's kind of hard to see, but K flash period is 25. Let me make sure I didn't meddle with my updates times. Okay, let me look at it again. Yep, I'm happy. So now let's make our particles move out at random angles and random distances. And to help with this, I'm going to make a polar vector class. Yeah, that's what I'm going to do. Not that, actually. Just a file. Just a file is good enough. That's all I want. Header file, polar vector. And this is just so we can have it be in terms of a magnitude and an angle, which is what a polar vector is, basically. So I'm actually going to make its data members public so that it's just easy to change. So it's going to be pretty typical struct, but it's just going to have a couple of getter methods like a getX and getY so that we can easily convert it to X and Y units. So let's have a units of game, and of course include units. For magnitude, units of degrees for angle, and then we can have a getX and getY in game units. That'll be const. We'll implement it here, but there's another thing I want to add to units, and that is a special sine and cosine function because I'm getting tired of converting units, converting from degrees to radians. So if I go into units.h, I can add those in here. How about right below here? Inline units of game, which is perfect, sine, and it'll take in a degrees. Actually, I don't need to scope in units of game. And this is just going to return standard sine taking in degrees to radians, degrees, and also converting it to units of game. So static cast this to game, right there, bam, done. And I'm going to do the same thing for cosine. So now I can just use units, cos, and unit sine instead of standard cos and standard sine in converting. So let's implement these right here. So getX is going to be the x component of our magnitude and angle combination. So it's the magnitude times the cosine, because that's what we associate with x, units, cos, angle. And same thing for y except for with the sine. Again, pretty simple class, but it's just going to help out a lot to be able to have this getX and getY separated. And yeah, so let's include this. Let's include this in our header file for headbumpparticle.cc, and then just build to make sure that it's all compiling correctly. Alphabetical order, I do that occasionally. Not always, but occasionally. And I'll make a polar vector. Oh, that's the other thing I want to have in my polar vector is a constructor. And it's going to take in a magnitude and an angle. Okay, so now I can add a polar vector, so this will be particle A. Build and run. Times has no, star has no effect. Oh, I need to return these. That's what you get when you're functional programming and then you forget that things want... Okay, great. Let's implement this constructor. Or let's particle A. And we can call it with a magnitude and an angle. I'm just going to do 0, 0, just to see if it compiles. Okay, finally it compiles. Now that we've built our polar vector and we know it's building, let's test it. And I'm just going to test it by making it move around a circle around a central point. So let's give ourselves another, don't hide everything. So let's give ourselves a central particle that we're going to rotate around and then actually draw this flashing particle that we have at the particle's location. So we'll do center x plus particle a dot get x, because this polar vector is relative to the center, or its position is relative to that center. So polar particle a dot get y, and then let's update our angle and like maybe rotate it around in a circle around 60 degrees per second. So particle a dot angle plus equals 60 degrees per second. So we're going to multiply times elapsed time. So let's divide by 1,000 to get milliseconds, and then multiply by elapsed time to get degrees. So this should work, and it should rotate around in a circle just going clockwise, I believe, because y goes down when it's positive. So that does not look like a circle. It looks like I'm not calling, it looks like I'm calling either cos twice or sine twice. So let's see, polar vector.h, get x is calling cos, get y is calling sine. That looks fine. So let's get units. Cos is calling sine, yeah, that's the problem. So let's have cos call cos, and sine is calling sine just to check, and now it should move in a circle. So let's build and run just to see, and wow, units is used in everything, so it takes a while to build. Boom, 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 boom. And after this, if this is working, we can make the actual effect. Finally, like just make it shoot outwards from a central point like it's supposed to. So build succeeded, let's run it. And yes, we see it moving slowly around this central point, 60 degrees per second. So it's, I'd say that's about 60 degrees per second. I'm happy with that. All right, so let's build the actual effect. Now that we know our polar vector is working, let's make it go off in different directions or random directions. So to do this, let's initialize our random stuff by calling srand, and we'll do this in our game class in our constructor. Just call srand, and srand is in standard lib. Again, it's a C function, but I'm okay with using it and not the boost random, just because this is a very low, I mean, we don't really need to overthink random for particle effects. And pound include time, because that's what we're going to use to initialize or to seed our random number. So srand takes in a static cast. It takes in an unsigned int, and time returns something not unsigned int, but we can just cast it and it'll be fine. So let's call time and just pass it null, because we don't need to get any, yeah. So this is how we initialize our srand. There's other ways of doing it. There's plenty of better ways of doing it, but you know, overthinking it. Particle effect. Yeah. Okay. So let's use a random value here for our angle, and then just make our particle go out in that random direction. So let's start by including standard lib. And so this is going to be in units of game, but rand returns an integer. So units of game, nope, units of degrees. And this is going to be rand, some number between 0 and 360. So let's just do modulo 360. And let's start our magnitude off at 0, and instead of updating our angle, let's update our magnitude. So let's do magnitude plus equals k speed times elapsed time. And let's define k speed, which I said was 0.12. velocity, its units of velocity, k speed equals 0.12f. So let's see how this looks. It should go off in a semi-random direction. Pseudo-random, I mean. Yeah, I didn't choose that direction. Let's make sure it goes off in a different direction now. That looks like a different direction. I'll try one more time. Yeah, that's a different direction. I mean, it looks like it's moving around kind of in a circle, the random direction, but you know, it's good enough for me for now. And if it turns out to be not good enough later, we'll fix it. And that is my promise to you. If it's not good enough, we'll fix it. So the next thing we need is to make a max offset. And to do this, I could make a struct, but I feel like that might be overkill for this case. So I'm going to do a const units of game. Game max offset. And then we'll just initialize this to a random number between 4 and 16-ish. So we'll call this max offset A. Max offset A. And this is going to be a random number from 4 to rand modulo 4, between 4 and 20. So that's rand modulo 16. And then let's make sure our magnitude never gets above that. So let's say max standard min this plus our current magnitude. So particle A dot magnitude plus that. And so the minimum between that and our max offset A. Now let's see how this looks, and then we can create just another one. So there's a conversion int, possible loss of data. So our max offset needs to be statically cast to units of game. Because yes, we really do mean to cast it. Build and run goes out a certain amount. Let's see it again. Let's see if it goes further. That was a shorter distance. That was a longer distance. Perfect. Okay, so I'm happy with how it is now. Now let's just do the same thing again. Again, I could wrap these into a struct, but I don't really feel like it. Actually, you guys totally can, and maybe you should too. But this is the only time I'm going to do this. So I don't really feel like I need to overthink this. This will be particle B, and this will be max offset B. And let's make sure we draw and update them. I just love copy and paste. As long as you know what you're doing when you're copying and pasting, and as long as you know all the code that goes into it, it is totally encouraged to copy and paste. But if you don't know what you're copying and pasting, don't do it, because you will get yelled at by people. So it looks like it worked out right, but let's get rid of our center sprite because we don't really need that anymore. Okay, build and run, and this is it. There we go. There is our head bump sprite, or our particle effect. And yeah, that's it. In the next episode, we're going to be building a particle engine to kind of keep track of all the particles, be able to create new particles, all that kind of stuff to, you know, make this actually part of the game and not just on a black background. But I thought it would be easier to demonstrate it on a black background. So let's actually bring everything back as one final hurrah. Everything's still there and updating, we're just not drawing it. And where do we want to draw our particles? Well, actually pretty much behind most things. I'm not sure if we draw it behind the enemies, but we I think we actually draw it in front of a lot of stuff. So in front of the map, but behind the damage text, that's what I'm going to do. See how that looks. There we go. Look at that. It's like, I just bumped my head. Ooh. Okay. So thanks for watching, guys. In the next episode, like I said, we'll make this like pop up wherever a quote is, but it's nice to have a particle effect to work with before you actually build the engine to house it. At least it makes more sense in my mind. So yeah, that's what I chose to do. And thanks for watching, guys. Happy developing.